To get the maximum benefit out of our test taking strategies presentation, it is best if you go to my website at louisalyons.com under Special Education, click on Lindsay McClellan, and download under the downloadable documents the test taking strategies PowerPoint. It is this PowerPoint, and if you print that, you'll have it to write on. It's most effective if you have this in front of you while we're actually going through the presentation. We're talking about test-taking strategies. These are things that will help you take your SOL test to the best of your ability. These strategies are designed to help you, but they only work if you do them in the way that we're suggesting. We suggest that you take your SOL in 3 waves. The first wave is going to be plug and chug. You're going to do these problems all the way through the test without stopping. Once you've finished all of your plug and chug questions, we'll go to the next 2 types of questions. However, we need to talk about what exactly plug and chug is. Plug and chug is specific to math tests. You're looking for keywords in problems that let you know that you can plug in information into the equation and find the answer. Your keywords are going to be problems that have f of x, value, zeros, solve, solution, and table. However, the key to plug and chug is that you must always replace the variables with parentheses before you input the variable's value. Another thing to be careful of is no matter if you're doing equations or inequalities, the goal when using plug and chug is to make both sides of the equation or inequality equal. Find the value for u plus xy if u equals 3, x equals 5, and y equals -2. Now this is a plug and chug question because of our keyword value. What this means to do plug and chug is that we are going to replace our variables in the problem with the values that they gave us. So we first replaced those variables with parentheses, which is key in plug and chug. From here, you input the value for u, which is 3, x, which is 5, and y, which is -2. 5 times -2 is -10, plus 3, which gives you -7. Solve the following equation. 3p minus 1 equals 5 times the quantity p minus 1 minus 2 times the quantity 7 minus 2p. Again, this is plug and chug because of our keyword solve. In order to test this for plug and chug, first rewrite the problem, but instead of putting your variable, you're going to replace it with parentheses, which I've already done for you on your screen. From here, I would start with my answer choices that are positive, just because positive numbers are easier to multiply by and you're less likely to make a sign error. So since our first answer choice, A, is positive, I'm going to test that first. The goal of plug and chug again is to have one side of the equal sign equal the other side of the equal sign. If you're testing letter A and you plug that into your calculator, you're going to get 8 equals 8. Since that is a true statement, A is your correct answer. Find the solution to the given system of equations. Y equals x plus 6 and y equals -2x minus 3. Since we have our keyword of solve, which you can't see on here because it didn't upload correctly, you're going to actually plug in your x values and your y values into the given equation. Again, first replace your variables with parentheses and then input the value. So if we're testing A, our y value is 7, and our x value is 1. 1 plus 6 does equal 7, but it has to work in both equations to be a true statement. So, negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. So that does not work in the second equation. Therefore, A cannot be correct. So we move along to B. Y is 3. X is negative 3. Negative 3 plus 6 is 3. 2 times negative 3 is negative 6. And negative 6 minus 3 is 3. It works in both equations. Therefore, B is your correct answer.
Find the solution to the given system of equations y equals x plus 6 and y equals negative 2x minus 3. Unfortunately, the PowerPoint didn't upload so you could see the keyword solve. However, this is going to be a plug and chug question. In order to use plug and chug, we will take our x and y values and put them in the place of x and y in the given equations. If we're testing equation A, we're going to take 7 and put it in the place of all of our y values, and 1 goes in the place of all of our x values. 6 plus 1 does equal 7. However, negative 2 minus 3 does not equal 7. Therefore, A cannot be your correct answer choice. So let's move along to B. Put 3 in for all of our y values and negative 3 for our x values. Negative 3 plus 6 equals 3. Negative 2 times negative 3 equals positive 6. 6 minus 3 equals 3. Because it works in both equations, B is your correct answer.
Write a function rule for the table. Again, this is plug and chug because of our keyword table. However, table is not always going to be a keyword. In order for it to work for plug and chug, you must have a table and equations so you can plug values into the equations. So we'll just start with A. Remember that f of x is another way to state y. Therefore, we're going to plug our x values into the equations that we're given and see if it equals our y values. So we're trying to say negative 3 equals, and our first x is negative 2 minus 1. Well, negative 2 minus 1 is negative 3. However, we have to make sure it's true all the way down the table. So, negative 1 minus 1 does equal negative 2. 0 minus 1 does equal negative 1. And 1 minus 1 equals 0. Because it works in all of the equations, A is your correct answer. Find the zeros of the equation 6x squared minus 20x plus 6 equals 0. Again, this is a plug and chug because of our keyword zeros. However, this problem is actually going to present us with a little bit of a challenge. The reason for that is because they gave us decimals. Specifically, decimals that are non-terminating. Therefore, these are rounded off. So it's going to be very hard for us to plug our decimals into the equation and get exactly 0. So we're going to get as close to 0 as we can. Now, if you notice, our answer choices are in brackets instead of parentheses. That's because we only have one variable in the problem, and it happens to be an x. When a problem has answer choices that are in brackets, that means that they are both representing a value for the given variable. So x in A is both 3 and 0.33. So both of those are potential x values. What this means is when you're testing an equation that only has an x but has multiple given values in the answer choices, you have to test each value individually. So let's test the first one. Looking at the bottom of your screen, if we test A, our first x value is 3. If you plug that into your equation, you will find that this portion of the problem equals 0. And since 0 equals 0, 3 is going to be a correct answer choice. But to make positively sure, we also need to test 0.33. When we test 0.33, and you should be typing these in your calculator along with me, you'll find that you're going to get 0.0534, which does not equal 0. However, if they give us an answer choice that has been rounded, we cannot expect to get the exact answer choice. But 0.0534 is very, very close to 0. Therefore, A is your correct answer choice. Backdoor or substitution method is going to be our second wave on the test. So at this point, before you ever start wave 2, you should have finished all of your plug and chug questions on the test. When identifying whether or not a problem is backdoor, you need to be looking for the keywords equivalent, factor, or simplify. Essentially what we're doing in the backdoor method is we're making up any value that we want for our variables. So it's something that you're just going to come up with out of your own mind. However, you should never use 0, 1, or 2 because sometimes using those numbers will give us a false correct answer. Which of the following is equivalent to 7x to the negative 8th power times 6x to the 3rd power? Now this is eligible for our backdoor method because of our keyword equivalent. If you remember how to use your exponent rules, it's probably much faster to complete this problem using your exponent rules. However, for those of you who were not very good at memorizing your exponent rules or get nervous on the test, this is another way that you can work this problem out. So we cannot use 0, 1, or 2 for our x values. So what I'm going to say is that x equals 3. If x equals 3, I replace all of my variables with parentheses and input 3 in their place. From here I have no more values left. Or no more variables left in the problem, therefore I can plug it straight into the calculator. When I plug this problem into the calculator with 3, it will equal, as a fraction, 14 over 81. So what I'm comparing is the value 14 over 81, and I'm going to try to get those same values in either A, B, C, or D. So again, if x equals 3, I need to test that in all of my answer choices. So if I say 42 over, and remember, we've got to put our parentheses, and put my 3 inside. If I do the math and say 42 divided by 3 to the 5th power, you will also find that this equals 14 over 81. Because we were looking for a 14 over 81 as our answer choice, so it would be equivalent A is the correct answer. 14 over 81 does equal 14 over 81. Simplify the expression. The quantity negative 7x minus 5x to the fourth plus 5 minus the quantity negative 7x to the fourth minus 5 minus 9x. Well, we know that when we are adding or subtracting polynomials, all we have to do is combine like terms. However, if you have forgotten that rule, our keyword simplified lets us know that we can actually do this using the backdoor method. Again, I am just going to say that x equals 3. What I would like for you to do is pause this presentation for a moment and work out the answer choices using x equals 3 and see what you come up with. For those of you who used x equals negative 3, you will find out that our original equation equals 178. When you plugged in your answer choices and you put x in for all the variables, or 3 in for all of your x's, you'll find that D also equals 178. Therefore, D is your correct answer. Factor the polynomial 2x to the third plus 4x squared plus 8x. Well, factor is our key word. If you have forgotten how to factor, you can use the backdoor method. Again, I am going to say that x equals 3. Therefore, we are going to put 3 into all of our answer choices for x. That's included in the original problem and all the answer choices. When we put 3 in for the actual original problem, we get 114. A, you get 114. When we plug 3 in for B, you get 222. C, 210. And D, they didn't do anything different to the problem at all, therefore it's a bad answer choice. Because our original was 114 and A was 114, A is our correct answer choice. Find the simplest radical form of the square root 288. When you do the square root of 288, you will get 16.97. 2 times the square root of 72 is also 16.97. 144 times the square root of 2 gives you 203.6, which is not what we're looking for. 4 times the square root of 18 gives us 16.97. So now we've got 2 answer choices with the same numeric value as our original problem. What about D? 12 times the square root of 2 also gives you 16.97. So how is it possible for a test to give us 3 answer choices that all have the same numeric value as our original problem? Well, because it says they want the simplest radical form, that means you are looking for the answer choice that has the smallest number under the square root sign. A had a 72, C 18, and D was a 2. Because 2 is smaller than both 18 and 72, that means that D is going to be the correct answer choice. The final wave of your test is going to be all the problems that you had not previously answered. There is no specific test-taking strategy for this portion of the test. However, there are 3 very important formulas that you should know. The first being slope-intercept form, y equals mx plus b. The second is the direct variation shortcut, y over x equals y over x. Third formula that you should memorize is y equals kx, and that is your direct variation equation. It is also important for you to know what a function is. A function simply means that no x values repeat. You can test functions using your vertical line test. If your graph passes the vertical line test, it is a function. Another thing to keep in mind is what domain and range is talking about. Domain refers to your x values and range refers to your y values. Find the domain and range of the relation, and is it a function? When we're talking about domain and range, one important thing to remember is that you do not repeat values that are listed twice. Another important thing to remember is that you are arranging the numbers from least to greatest. So looking at the table shown on your screen, and the answer choices given to the right, A is a bad answer choice because 29 for your x value, your domain value, is listed twice, and we know we cannot have an answer choice listed twice. So A is bad. That also means that B is bad because 29 is listed twice again, and 37 in the range is listed twice. C also has 37 listed twice in the range. Therefore, your only correct answer can be D. However, let's talk about why D is correct. 29 is your lowest x value, 36 is the next lowest, and 65 is your highest. So that takes care of the domain for D. The range lowest value is 17. Your next lowest value would be 37, and your highest value is 42. Again, D is the correct answer. Find the domain and range, and is this a function? From here, you may want to zoom in on your screen so you can get a close-up of the coordinate plane. To do that, put your cursor over the screen and you'll see a magnifying glass. Just tap the screen and it will zoom in. Once you've zoomed in, you can see the coordinate plane close up. All of the points on this graph are included in this domain and range. However, we need to figure out how we are going to list it. Again, if we are arranging our domain from least to greatest, our least x values are in the negatives, and as we go towards the right, our domain values get higher. Therefore, start at your lowest, or your point that is farthest to the left, and find its value. So we have -7. Our next value is going to be -4, -2, 0, 2, 4, and last is 5. So those should be written in order from least to greatest for your domain. With that in mind, looking at the range, if we're going to arrange it from least to greatest, our least range values are going to be towards the bottom of the coordinate plane. So you're going to look from the bottom to the top. Our lowest value is going to be -5. The next lowest is -4. We've got two values at -2, however, we're only going to list it once. We also have two values at +3 that we're only going to list once. And our highest range value is 7. Looking at whether or not this graph is a function, you're trying to see if these points pass the vertical line test. Anywhere that you draw a vertical line you will see that the line only passes through one point at any given time. Therefore, this graph is a function. Direct variation. It's important. Direct variation. It's important whenever you have a word problem that you read it completely. The distance a spring will stretch varies directly with how much weight is attached to the spring. If a spring stretches 9 inches with 100 pounds attached, how far will it stretch with 90 pounds attached? Round to the nearest tenth. In direct variation, you must find your keyword varies directly. Whatever comes before varies directly is your y in the problem, and whatever comes after varies directly that you're comparing is your x value. We're comparing our y, which is distance, over the weight, which is our x. So if we say distance over weight and it tells us that the spring stretches 9 inches, inches is a distance, so we have 9, and it says 100 pounds, 100 pounds is a weight, so we should have 9 over 100. And that is going to be set equal to, it's asking us how far will it stretch. So we don't know the distance, but we do know the weight, which is going to be 90 pounds. Therefore, if you cross multiply and divide, you will see that 8.1 is the correct answer. If you're not comfortable with cross multiplying and dividing, you can compare 9 divided by 100 as a decimal with 8.1 divided by 90, and compare those two decimals and you will see that they're equal. Match the slope to each line. Whenever we're trying to determine slope from a graph, on whether it's positive or negative, read from left to right. If the line is going downhill, then it's going to be a negative line. If the line is going uphill, reading left from right, then it's a positive line. Therefore, B should be your negative line, and A should be your positive line. A horizontal line is always a zero slope, and vertical lines are always your undefined slope. Find the x-intercept of y equals 2/3 x plus 4. One way to do this problem would be to graph it. Start at the y-intercept, rise 2, run 3, or go down 2 and back 3. And you could repeat this process until you got this line. Or you could recognize that anywhere on the x-axis, your y value is always going to equal 0. If you recognize this, you can plug 0 in for y and solve for x. 0 equals 2/3 x plus 4. First of all, we'd like to get rid of this fraction. So you must multiply the entire problem by the common denominator, which was 3. When you distribute 3 to all of the terms in the problem, 3 times 0 gave you 0. 3 times 2/3 gave you 2x, and 3 times 4 gave you 12. From here, you need to subtract 12 from both sides, and you're left with negative 12 equals 2x. Divide both sides by 2, and you get x equals negative 6. Remember that x-intercept is a point on the graph, so you should have negative 6, 0 as the coordinate. Find the slope and y-intercept of y equals 3x minus 8. We recognize that this equation is currently in slope-intercept form. Therefore, my 3 is in the place of the slope, and negative 8 is in the place for the y-intercept. So our slope is 3, and the y-intercept is negative 8. Find the slope and y-intercept of 5x minus 6y equals 30. This equation is not currently in slope-intercept form. Therefore, before we can answer the question, we first must solve the equation for y. To do this, subtract 5x from both sides, which leaves us negative 6y equals negative 5x plus 30. Divide everything by negative 6. And you're left with y equals 5 over 6x minus 5. Now that the problem is in slope-intercept form, we recognize that 5/6 is our slope and our y-intercept is negative 5. Find the slope and y-intercept of the graph below. Y-intercept is pretty easy to recognize because it's where it's crossing your y-axis. So our b is positive 1. Slope, we need to do rise over run. If we rise and run, you'll see that you rise 3, run 2. However, it's very important to recognize that this line is a negative line. So your slope is negative 3 over 2. And again, the y-intercept is 1.